Not sure what happened with the video there, but let's keep going. So no matter what the x value is, it doesn't matter what the x value is, the slope of this equation is always going to be -3 when the y value is -3. So we can fill in the rest of those. Okay, so then we're going to do the same thing. So at the point 3, -2, the slope is going to be -2, the slope of the original function, because that's what this says. The slope of the original function equals y. So the slope of the original function at the point 3, -2 is -2. The slope of the original function at 2, -2 is still -2 because the slope's always y. So the same thing here, -2, -2, -2. The slope is always -2, right? Okay, what's going to happen at -1? Well, the slope of the function, the slope of the original function, the derivative, is always y. So this is going to be -1 all the way down, because the slope of the function is y, and these are your y coordinates, and these are x. Okay, what about at 0? Well, it's going to be 0. Okay, at 1, it's going to be 1. At 2, it's going to be 2. Where y is 3, it's going to be 3. So your x value does not affect the slope of this original function, okay? So this is just what the slope is going to be at each of these points, the slope of the original function. Okay, so if the slope of the original function, we know what this is, we could take these points and graph the slope of the original function and figure out kind of the shape of what the original function has to look like, okay? So let's see, when x is 3 and y is -3, so that's 3, -3 right here, the slope is -3. Okay, well, we can't really do down 3 over 1, so up 3 over 1 would kind of look like this. And you're just going to draw a little mark because it's just at that specific point, but you want enough of the line that you can kind of see what's going on. Okay, what about at, so I know that all of the y coordinates of -3, so all of these points right here, have a slope that's -3, because the point 2, -3 is -3. 3 is -3. All of these are -3. All of those have a slope of -3. And you're just kind of sketching as best as you can. What about all the y values of -2? Well, they're all -2, so they're going to be slightly less steep. All of these values right here. Okay, at -1, they're all going to be -1, so they're slightly less steep again. And they don't have to be perfect. You're just kind of getting a general idea of what this is going to look like. At 0, they're all 0. Okay, so they're all just horizontal. Okay. At 1, they're 1, so we've switched directions. At 2, when y equals 2, they're all 2. So again, I'm just trying to guesstimate about what that slope would be if I went down 2 over 1. It would look something like that, just a little one. And then at 3, they're all 3, so down 3 over 1. So I'm going to kind of aim towards this dot right here, and then just kind of make these all the same. Okay, so this is a representation of the slope at every specific point of the original function, no matter where that function might originate, right? Because you'd have that plus c if we took the integral, so you don't really know which function it is. So if we're doing this, this is giving us a generic shape for the function, okay? So if they want us to find the specific solution going through 1, 1, well, here's the point 1, 1. So if we're taking about the point 1, 1, this function should kind of follow this curve up this way, because it would follow the slope, right? That's the slope of the tangent line. So then it comes in like this, because it wouldn't curve back down, because then it wouldn't be a function, right? So the function at 1, 1, this is a right here, should look kind of like that. Okay, so it just kind of follows the curve. So you can see that this could be the function anywhere. So you could find what this function looks like at -1, 2. Well, at -1, 2 would be the same function curving through here because it follows that same slope. They also want you to find b at -2, 0. So -2, 0. So there's that function. Okay, well, we don't really know where it's going to go. We don't know if this is the horizontal or what's going to happen. So it's kind of almost impossible to find it here because it's so flat. Okay, so they won't ask you to do that on an AP test, but they will ask you to find this point. So this point for 2, 2, I'm going to just let it be the same curve. So we'll let this be A and B. Okay, and that's it. That's a slope field. You literally figure out what these points would be at Y, and no, you're not going to have to fill out a chart every time on the AP test, but it's just kind of an easier way to see what's going on. On the last few free response questions, there has been at least one where you have to fill in about 6 or 7, maybe 8 dots on the slope field, and then you have to sketch the curve through the specific point, okay? But it's really easy. You just plug in the X's and the Y's where they go, and away you go, okay? So that'll be the end of this video, and then we'll do the next example in the next one.